In this video, we're gonna solve some problems that show up when integrating using power rule. So first of all, the formula is integral of x to the n dx equals x to n plus 1 over n plus 1 plus a constant for any real number except negative 1. And we'll see what happens at negative 1. So the formula says just add 1 to the exponent and divide by that number. So let's look at some examples. We have integral of x to the third dx. So based on the formula, n equals 3. So we have to go, we are calculating the integral. We go x to 3 plus 1 over 3 plus 1 plus a constant. So that gives us x to the 4 over 4 plus c, or you can have 1 over 4 x to the 4th plus c, but this is all there is to it. You just add 1 to the exponent and you divide by n plus 1. Now you can quickly check by taking the answer that we got and differentiating with respect to x. So now we go use the power rule for differentiation, and we have 1 over 4 times 4 x to 4 minus 1, which is 3. A constant prime is 0. These two cancel, and we obtained x to the third. So we calculated integral of x to the third dx. But the power rule can be used in other situations, like in example 2. So if we look at example 2, we have integral of square root of x dx. And we know that n root of x to the m can be written as x to m over n. So we can change from a radical notation into a rational exponent. So in our case, we are going to have integral of square root of x dx is going to be integral of x to 1 over 2. Why? Because the index of the root is square root, so it's 2, we don't usually write it. And the power of x, it's 1, we don't usually write if we have 2 to the first or 3 to the first, because it's just exactly that number. So change it from radical notation into rational. We get integral of x to 1/2, which based on the formula we have x to 1/2 plus 1 over 1/2 plus 1 plus a constant. So we get x to 1/2 plus 1 is 3 over 2, then divided by 3 over 2 plus c. But of course we are gonna arrange this a little bit. So x to 3 over 2 and then divided by 3 over 2 means times 2 over 3 plus c. Since our original problem was in radical notation, we are going to write in radical form the answer as well. So it's 2 over 3 square root of x to the third plus c. But in math, we always simplify our answers. So it's going to be 2 over 3 x square root of x plus c. So taking a look at the original problem, and we get 2 over 3 x square root of x plus c. Now we can have another type of example, like cube root of x to the second dx. And as you probably noticed, we're going to use the same formula of changing from radical notation into rational exponents. So cube root of x to the second, it's x to 2 over 3. And so we have x to 2 over 3 plus 1 over 2 over 3 plus 1 plus a constant. So we get x to 5 over 3 over 5 over 3 plus a constant. Now the 5 over 3, we can flip it into a 3 over 5, and then we write cube root of x to the fifth. We change it back into a radical form. But we also notice that we can simplify the radical. Instead of x to the fifth, we can write x to the third times x to the second. And the reason why we chose 3 plus 2, it's because the index is 3. So we can simplify it into cube root of x to the third times cube root of x to the second plus c, and this gives us 3 over 5. If the index is the same with the exponent, we just get x and cube root of x to the second plus c, and we found the answer for problem 3 as well. Now let's take a look at example 4, which is a little bit different than the previous problems. We have integral of 1 over x to the 4th dx. So in this case, we are going to use the fact that if we have 1 over x to the n, we can write it as negative exponent as x to negative n. So this problem here, let me write the formulas with red. So the problem becomes integral of x to negative 4 dx, and we just apply the formula x to negative 4 plus 1 over negative 4 plus 1 plus a constant. This gives us x to negative 3 over negative 3, and we are going to arrange it a little bit. The problem started with positive exponents, so we are going to move it back into negative 1 over 3x to the third plus c. So when we start with a negative exponent, we write our answer with negative exponent. When we write radical, we end with radical. The same with numbers. If the problem started with decimals, even if we use fractions, we finish the problem using decimals. Okay, so let's take a look at the next one. So again, it's power rule, but this time we're going to use the fact that when we have 1 over n root of x to the m, that can be written as 1 over x to m over n, which means x to negative m over n. So we are using, we are changing that into rational exponents, but in this case, it's going to be negative as well. So it's going to be x to negative 3 over 5 dx, which we can find again using the formula x to negative 3 over 5 plus 1 over negative 3 over 5 plus 1. And so we get x to 2 over 5 over 2 over 5, which means 5 over 2, x to 2 over 5. And that means 5 over 2, fifth root of x to the second plus c. I wrote the c just at the end. This term, because the power of x it's less than the index, we cannot simplify it anymore. And now the last problem is what happened at n equals negative 1, right? Because we said the formula works except when x equals negative 1. So the problem was that if x is to negative 1 and we try to use the formula, we get x to negative 1 plus 1 over negative 1 plus 1, which gives us x to 0 over 0, which is undefined. So this doesn't work like that. We cannot use the formula in this format. So what we are going to do is we write integral of 1 over x dx, which is absolute value, ln absolute value of x plus c. So this is the correct formula. This is something that explains to us why n equals negative 1. It's not appropriate to use the power rule when we integrate. I hope this helps. And before we conclude this, let's solve a problem. Integral of 1 plus 2x squared, everything to the second dx. So how do we solve this problem? Well, first of all, we notice that we have an a plus b squared. And please don't write a squared plus b squared like some people write it wrongly. To write a squared plus 2ab plus b squared. So it's going to be 1 plus 4x squared plus 4x to the 4th dx. Now this integral can be separated into three integrals. So it's integral of dx plus integral of 4x squared dx plus integral of 4x to the 4th dx. And the reason I chose this problem is because, well, integral of 1 dx or dx is x plus, but in the next in the next integrals we have some constants, and I want to remind you that when we have constants, the constant comes in front of the integral. So I'm just going to write this in front of the integral first, and then we're going to calculate them. So we get x plus 4 times x to the 3rd over 3 plus 4 times x to the 5th over 5 plus a constant. And if we rearrange it, it's x plus 4 over 3x to the 3rd plus 4 over 5 x to the 5th. So plus constant. I hope this helps.